Hello and Assalamualaikum. My name is Afi Humaydi bin Muhammad Zalani, Numeric AE 2033. My part is solution. For the question 1, we get the circuit. We have the circuit, current source, inductor, capacitor and resistor. The question 1 is, design your circuit to obtain an overdamped, critically damped and underdamped response that the radiant frequency W equal to 500 radian per second. Use a standard component value in the design. Firstly, we need to apply KCL. IR plus IC plus IL equal to IS. We change to standard form and we differentiate first and second differentiation and we get the characteristic equation is S square plus 1 over RC S plus 1 over LC. From that, for S1 and S2, the formula negative 1 over 2 RC plus minus 1 over 2 RC square minus 1 over LC square. And into negative alpha plus minus alpha square minus 2 naught square. For next, we from the value given W naught 500 radian per second and inductor do not given. We assume L inductor as 1 Henry. We get from that we get the capacitor equal to 4 microfarad. The formula ILT equal to ISS plus IT and VCT equal to VSS plus VT. Okay. First, for the overdamped case, alpha equal to W naught. Alpha bigger than W naught. We can from that we get the R. From that we need to find the R. We get R less than 250 ohm. So I choose 150 ohm. We get the alpha at 33.33 radian per second. From that we get the W naught. We will get S1 negative 168.67. S2 we get negative 1500. From that VCT, VSS into VT, we are at VCT 0 equal to 30. We get V30 equal to A1 plus A2. For differentiate with T naught, dVc over dVc over dt equal to A1 S1 plus A2 S2. From that we get dV naught over dt. We get 9 over 5 divided by 4 microfarad. We get 550,000 voltage per second. We get two equation. We combine and we get A1 371.25 and A2 negative 341.25. We put to the formula. For the ILT equal to ISS plus IT, we get from that we get negative 2 equal to I1 plus I2. We differentiate with T, we get I1 S1 plus I2 S2 equal to DIL not over dt. We get from that we combine and we get A1 negative 2.228, A2 0.228. From that we put to the formula and we get ILT 4 minus 2.228 exponent negative 11.670 plus 0.228 exponent negative 1500 T. Secondly, critical damped case. Resistance equal to 250 ohm. So we get the alpha equal to W 500 radian per second. From that, we for VCT I1T plus A2 exponent negative 500 T. ILT equal to IS plus I1T plus A2 exponent negative 500 T. To get the ILT equal to IS plus I1T plus A2 exponent negative 500 T, we at T0, we get the A2 negative 2. Next, di over dt, we differentiate and we get the formula I1 exponent negative 500t negative 500, A1t exponent negative 500t, negative 500, A2 exponent negative 500t. Secondly, from the differentiate di dt note, we get the A1 negative 970. From that, we get ILT equal to 4 plus negative 700 negative 970t negative 2 exponent negative 500t ampere. To get the VCT, we need to ILT differentiate. So we get the 485,000 T plus 30 exponent negative 500t ampere per second. We put VCT equal to L DIL over dt. We get the formula 485,000 T plus 30 exponent negative 500t. Third, other than case, alpha less than W naught. So when we want to get the resistance is bigger than 250, I choose 300 ohm. The alpha we get 401.67 radian per second. For the formula, to get the ILT, ILT equal to 4 plus B1 cos 276.38t plus B2 sin 276.38t exponent negative 416.67t. We get at IL naught, we get B1 negative 2. For di over dt, naught, we get 30. di naught over dt naught equal to 30. We get B2 negative 2.91, and we get the form we put to the solution to the formula. For the VCT, from di over dt, from IT we differentiate the ILT, we get the VCT. From that we get the answer, the VCT. Alright, for the question 2, the question have two power supply, VS1 and VS2. For the question A1, we need to find the I1, I2 and V naught. Alright, firstly we need to find the R1, R2, C1, L1, L2 and L3. At that you can see, and when the power supply one only choose, we can get at there, we get the resistance total, we get 29.45 degree, 43.68 degree. From the VS1 source, I1 we get negative 56.309 plus 61.04 imaginary. I2 we get 1.323 degree 54. IC we get negative 0.164 degree negative 155.7. From IC we get V naught, IC time negative 200J, we get 32.83 degree 114.25. At voltage source 2, we get the resistance total, we get 34.161 plus R83.087 imaginary. I naught is 0.891 degree negative 7.65. I2 we get 0.346 negative 1.125 imaginary. I1 we get 0.979 angle 140.8. For V naught, we get 60.159 angle 1.394. From that, we can combine to get the solution. I1, we combine both sides. We get I1t 4.068 cos 100t plus 47.68 ampere. I2t, we get 2.237 cos 100t plus 78.87 ampere. From V0t, we get 56.237 cos 100t plus 33.94 degree. Thank you.
Okay, Assalamualaikum, and my name is Ec2, and I will explain to you how I did the simulation for part simulation for question number 1. This is the circuit. Pretty simple circuit. We have an inductor with the value of 1 Henry and initial current is 2 ampere, and then the capacitor, which is 4 micro, have been calculated in the report by my friend, and the initial voltage is 30 volt. Okay, the resistor for the overdamp, the first case, overdamp case, is 150 ohm, and here we are going to see the graph for overdamp case. I have set the end time to 90 millisecond, and then the output is current, negative current, and then the voltage is negative voltage. I put the negative so that the volt graph will go up, and then the current graph will go down. Okay, then we simulate, and as you can see, this is the graph for overdamp case. Yep, 90 millisecond. This is the volt, which you can see in the report, and then this is the current. I've actually zoomed in on this to make it look so that we can see it is actually wait a minute. Yeah, we have some value here. It's just the value is small, can't really see what's going on, and if we put the voltage, it's gonna be big. Alright, so the next is critically damped, which is the resistor is 250 ohm. Let me just simulate. Here is the graph for critically damped. It goes down faster than overdamp. And then the current, well, I've shown you in the report. And then for the last case is underdamped, 300 ohm. Simulate. Yes, here it is. Now in the report, I missed showing you this. It's actually, it goes down a bit. It oscillates. Yeah, you can see that it goes down and then up and then steady state. That is under them. Yes, under them. Okay, that is all from me. Thank you.
Assalamualaikum and hi. My name is Nur Hamiza bint Rasman. My metric number is CE200119. I will explain for question 2. The circuit in question 2 is operating in the sinusoidal steady state. We are already given Vs1 equal to 120 cos 100t plus 90 degree volt and Vs2 equal to 80 cos 100t volt. Then we need to simulate the steady state current and voltage, which is I1, I2, and V out. Then we need to plot the steady state current and voltage. So this we use multisim to simulate this question. Okay, I already designed the circuit based on question 2 in figure 3.2, and I already set 120 volt, 15.92 Hz and 90 degree in V1. Then V2 I already set 80 volt, 15.92 Hz and 0 degree. So this is the value for I1, I2 and V out. Okay, this is the graph for V out, I1 and I2. Okay, this is the graph for V out. Then for this is the graph for I1 and I2. So that's all from me. Thank you.